Okay, welcome back. So I want to prove this this guy right here. And we don't know much about vectors. I certainly right, we don't know that. We haven't, I mean, I'm telling you this, but we haven't proved it. And because this is vector, it's a new thing. So we have, the only way we know, what do we know really? The constant we know. So let's see how we go about doing this proof here. Come on. You gotta be super logical when you do these proofs. Here we go. So I can start with this A, U plus V. And I don't know much right now. Right, I haven't proved any of those properties. I'm going to prove this one. So up till now, the only thing I know is the components. So I can go ahead and write these in terms of components. So there's my constant A times, okay, I have component U1, U2 plus V1, V2. Oops, that needs to be this way. There we go. Okay. And I know addition with vectors, I can add the components. So that's what I'm going to do now. I'm going to add my components here because I have addition with components. So U1 plus V1, comma, U2 plus V2. I have that. Which means, and I have the A. I know that my A can distribute into my components. Right, so we've got that part. So this is what we can use. This guy right here. We can use that. And we're using this fact because we've got this already. Okay. And that you can write your vectors in component form, these guys over here. Right, so those are the only things I've been using. Can't use any of my properties. Right, when you're proofing things. Okay, so come on. Go one little bit more. There we go. Okay, so I know that my constant is allowed to come back inside here. So we have U1 plus V1, comma A times U2 plus V2. There, I've got that vector. And I know these are just scalars, right? So I can distribute scalars, no problem. So I get A U1 plus A V1. I have A U2 plus A V2. I have that. And now this was just addition, right? Here. I went from here to there. That was just adding my components. So now I'm going to go backwards, right? So see how the U1 goes here, and then here's the U2 goes that way. So I can rewrite this as AU1, comma AU2 plus the vector AV1, comma AV2. So I just did the backwards. I went backwards for my component addition. And now, right, that's the other one I used. I can bring my constant inside to the vector components. Here's the A inside the vector components, and so I'm going to pull it out. So I'm going to pull out the A, and I'm going to have U1, U2, and I'm going to pull this A out. I'm going to have A times the components V, V1, comma V2. And this is A U in vector form plus A V in vector form. So that's how you have to prove these properties that are above. And I just did one for you. Okay. Alrighty, so let's go back and look some more at magnitude. Alright, so where'd you go? Why was this not? Oh dear, I hit something. Stop! Sorry. Sorry. My pen goes into a mode where it just keeps on, it connects everything. Not writing. Okay. Okay, so magnitude means length of a vector. Okay, so let's just put in a vector. There's the vector. Okay, and I'm just going to put it on, coordinate axis. Right, so remember this length here is U1. And this length here is U2. Which means this point right here is the point U1, comma, U2. Okay. And we're looking for here, this length. We're looking for this length. Okay. And I know that we can write that length as this. Right, I already gave you that notation for magnitude. All right, so how do I find that length? Well, that's the distance between this point and that point, square rooted, right? That length is the same as our distance, which was U1 minus 0 squared plus U2 minus 0 squared, all under the square root. And of course, I don't need the 0, so we get U1 squared plus U2 squared. That's distance. That gives me the length of that vector, and we write this like that. Okay. So what is this? Let's go ahead and see if I can come up with what these are. U1 is 1, 2, 3, 4, 5, 6, 7, 8. And U2 is 1, 2, 3. Right? So magnitude of U here is 8 squared plus 3 squared, square rooted. So 64 plus 9, which is 53 in the square root. Oh, whoops. Okay. Where's my time? Okay. Let's see a little late. Okay. So let's just look and see how we can come up with some of these vectors. All right. So now we're going to be given a point, 1, 3, 2, and Q, 2, 12, minus 9. So these are 2 points. Okay. And let's let U be the vector from P to Q. Okay. So now I have to come up with this vector P to Q because I'm not starting at 0, 0, 0. Remember, right? So I'm going from P to Q. So the way we do that, right, is how do I want to do this? Do I want to do Q1, Q2, Q3, or X? I guess X. So X2 minus X1, Y2 minus Y1, and we'll go Z2 minus Z1, right? So we would write 2 minus 1, 12 minus 3, and minus 9 minus 2, and that would give me 1, 9 minus 11, and I'm just going to write it the other way. This would be I plus 9j minus 11k. Right. So the displacement vector from P equals x, y, z, and q, which equals, let's do x1, y1, z1, and x2, y2, z2, which is because I got it exactly up there, okay, is u equals pq. So you kind of have to know where you're starting and where you're ending, because this means start, this means end. Otherwise, you'd have to go backwards, because this is showing that we're starting at P and going to Q. Okay. And this is x2 minus x1i plus y2 minus y1j plus z2 minus z1k, which of course you could also write as x2 minus x1, comma, y2 minus y1, comma, z2 minus z1. There you go. All right. Okay, and now we're in 3, right? We're in 3. So the magnitude here when you're in 3 space, right? There's I, J, K. There's our 3 different points. So we need magnitude now in 3 space. So magnitude of 3 space, well, in 2 space, we would have done u1 squared plus u2 squared all under the square root. And now we're just going to add the third one, u3 squared. Okay. So this works out to be u1, comma, u2, comma, u3, comma. So this is u1, this is the u2, this is the u3. Okay. Addition in 3 space is the same as in 2 space, right? So addition in 3 space, 3D is the same as 2D, right? If U equals U1, U2, U3, and V equals V1, V2, V3, right? Then U plus V equals U1 plus V1, U2 plus V2, comma, U3 plus V3. Right, so nothing different there. Same with, lambdas, right? So lambda V is going to be lambda V1, lambda V2, and lambda times V3. Right? Same thing. Subtraction works the same. Right, so 3 space is not really any different than 2 space. Okay, so where are we here? I think I'm going to stop there because we get into some angles, cosine thetas in the next video. So that's, hopefully we've got all that done. Well, I'm not sure when you... So we're in 13.2. I just didn't have it ever announced in my notes. Isn't that funny? Well, there you go. I will see you in the next video.